What if this robot could predict what happens next? Not just recognize an object, but understand what that object is about to do. That's a very different kind of intelligence, because teaching a robot to move is relatively easy. Teaching it to understand our chaotic world is something completely different. For decades, we've taught robots to follow instructions. If this happens, do this. If an object is here, move there. If something blocks the path, stop. And in a controlled environment, that works remarkably well. Welcome to Social Tech Guru. Factories are perfect examples. The robot knows where everything is. The objects are predictable. The lighting is controlled. And the same movement can be repeated thousands of times. But take that robot and put it inside a normal human home. Suddenly, everything changes. The chair isn't where it was yesterday. Someone left a bag on the floor. A person walks across the room. A dog suddenly changes direction. The lighting changes, and the robot encounters something it has never seen before. This is the fundamental problem with robotics. The real world doesn't follow a script. And here's the interesting part. Humans don't navigate the world like that. We don't calculate the exact coordinates of every object before walking across a room. We don't consciously measure every distance. We simply look, understand, predict, and move. You see a chair in front of you. You don't need a manual telling you what to do. You just walk around it. You see a glass near the edge of a table, and you instinctively understand that pushing it could make it fall. That ability, that intuitive understanding of space, is incredibly difficult for a machine to reproduce. And that's why vision is becoming so important in modern AI. Instead of programming every possible situation, researchers are increasingly trying to teach neural networks to learn relationships from experience. And one of the most interesting forms of experience is video. Think about how humans learn. A child doesn't need someone to write 1,000 rules explaining how a cup works. They watch people, they interact with objects, they make mistakes, and over time, they build an intuition about how the world behaves. AI researchers are trying to capture part of that process. OpenAI has already explored an important piece of this idea through video-based learning. In its video pre-training research, an AI agent learned useful behavior by watching large amounts of unlabeled online video. The original demonstration was inside Minecraft, but the bigger idea is much more interesting. What happens when a machine can learn simply by watching? Because video isn't just a collection of pictures, it contains actions unfolding through time. A hand reaches toward an object. The object moves. A person walks around an obstacle. Something falls. Someone reacts. And hidden inside those sequences is information about how the world works. But watching isn't enough. The real breakthrough happens when the AI can start asking, what happens next? Imagine a robot looking at a table. There's a glass near the edge. A person reaches toward it. The robot shouldn't simply recognize that's a glass. It needs to understand something deeper. If that object is pushed, it could fall. That's the beginning of what we might call spatial intuition. The machine isn't just recognizing objects, it's learning relationships. Above, below, behind, inside, near, far, moving, stationary, possible, impossible, and most importantly, cause and effect. But there's another massive problem. Even if you can train a robot in simulation, how do you make that robot work in the real world? This is known as the sim-to-real problem. A simulator can create millions of training scenarios, but reality is messy. Friction changes, objects deform, lighting changes, sensors are noisy, people move unpredictably, and tiny differences can cause a robot to fail. That's why researchers have spent years trying to make robots less dependent on one perfect environment. Instead of teaching a robot one world, you teach it to survive many possible worlds. Different rooms, different lighting, different objects, different surfaces, different situations. The goal is simple. Don't teach the robot one version of reality, teach it how reality can change. Now imagine combining these ideas. A robot sees a cluttered room. Instead of immediately moving, it considers several possible futures. What happens if I move left? What happens if I move right? What happens if that person suddenly moves? What happens if I reach for this object? What happens if the object slips? The robot doesn't need to physically try every possibility. It can evaluate potential outcomes before committing to an action. Almost like a person thinking, if I do this, then that might happen. And that's where world models become so interesting, because the goal isn't simply to recognize the world, it's to build an internal model of how the world changes. And this is where the real test begins. Not a clean laboratory, not a factory floor, a human home. Because homes are unpredictable. A robot might encounter a completely unfamiliar room, a new piece of furniture, a child running past, a pet suddenly changing direction, an object it has never seen before. And the robot can't simply say, "This situation wasn't in my programming." It has to generalize. It has to adapt. It has to understand enough about the environment to make a reasonable decision.
And that's the difference between a machine that performs a task and an adaptive agent.
Think about the difference. A traditional robot might be built to pick up a box. Another robot might vacuum the floor. Another might move products around a warehouse. Each machine has a specific job. But a general-purpose AI robot could potentially learn the concept behind the task. Instead of saying, "Move object A from position X to position Y," you could say, "Clean this room." And suddenly, the robot has to figure out what that means. What is trash? What should be moved? What shouldn't be touched? Where should things go? Which path is safest? And what should happen when something unexpected occurs? That's no longer simple automation. That's reasoning inside the physical world. And this represents a fundamental shift. The old approach was program the robot. Then came train the robot. The next generation may be let the robot learn the world. But don't get too excited just yet, because there's one enormous problem. A chatbot making a mistake can give you a bad answer. A robot making a mistake can break something, injure someone, or create a completely new safety problem. Physical world AI has much higher stakes, and that's why robotics still has enormous challenges. Reliability, safety, hardware, energy, latency, data, and perhaps the biggest challenge of all, generalization. A robot can't be considered truly intelligent just because it succeeds in a controlled demonstration. The real test is what happens when everything goes wrong. But imagine, for a moment, that these problems are solved. Imagine a future where you don't program a robot for every individual task. You simply tell it, "Take care of the house." And it understands what that means. Not because someone wrote millions of rules, but because its AI has learned enough about the physical world to figure things out. It can see a room, understand what's happening, predict what might happen next, choose an action, and adapt when reality changes. That's the real promise behind this entire direction of research. Not robots that simply look human, not robots that simply move like humans, but machines that can understand the world well enough to act inside it. And if that happens, the question changes. It isn't, what task can this robot perform? The question becomes, what can't it learn to do? Because once a robot can see, predict, reason, and adapt, it can potentially move far beyond the factory floor, into warehouses, offices, hospitals, and eventually our homes. For decades, we've tried to make robots fit into our world by changing the world around them. Structured factories, marked floors, fixed positions, controlled environments. But perhaps the better solution is the opposite. Teach the machine to understand our world. Because once a machine can see, predict, reason, and adapt, something fundamental changes. The robot is no longer simply following a path. It's responding to the world around it. It's making decisions. It's dealing with uncertainty. It's learning from experience. And that could be the moment robots finally leave the factory floor. We're entering a fascinating new era, where AI isn't just learning to understand information, it's learning to interact with reality. And this is exactly the kind of transition we'll be following here at Social Tech Guru. Artificial intelligence, robotics, emerging technology, and the ideas that could change the way we live and work. So, if you want to see where this technology goes next, subscribe to Social Tech Guru, because the next breakthrough might not happen inside a computer. It might be standing in your living room.